Good morning. All right, so today's lesson is over exponents, perfect squares, and powers of 10. So you should have done maybe a little bit of work with last year with exponents. So first of all, when you see something like this is read 3 to the 4th power. So first we're going to write 3 to the 4th power. That's how you would read that. The 3 is called the base, and the 4 is the exponent. So this is what 3 to the 4th power means. 3 to the 4th power means that you're going to take the base of 3 and you're going to multiply it times itself 4 times. Well, we know 3 times 3 is 9, and we know 3 times 3 is 9. So 9 times 9 is 81. So 3 to the 4th power is equal to 81. This one could be read 2 different ways. So this one could be read as 5 to the 3rd power, but anytime that your exponent is the number 3, we're going to read it as cubed. Now, this is what this means. If you can picture a cube, like a Rubik's Cube or a number die if you're playing a game. So if this had 5 layers, so we've got 1, 2, 3, 4, 5 going that way, 1, 2, 3, 4, 5 going that way, and 1, 2, 3, 4, 5 going that way, and so on. We would have 5 layers times 5 rows going up, okay? So that would be a cube of 5 by 5 by 5. So 5 cubed means we're going to multiply 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5 is 125. So you could say that 5 cubed is equal to 125. So that means if this cube over here was 5 by 5 by 5, there would be 125 small cubes making up that large cube. That's what that means. This one is read 9 to the 4th power. 9 to the 4th power, and that means 9 times 9 times 9 times 9. So 9 times 9 is 81. 9 times 9 is 81. Now we have to multiply 81 times 81. So I'm going to come over here. We all know how to do 2 digits by 2 digits. So 1 times 1 is 1. 1 times 8, put your 0 placeholder. 8 times 1, and 8 times 8 is 64. 8 plus 8 is 16, 5, and 6. So remember, if you need to pause this video at any time if I'm going too fast, go ahead and pause, and then you can back it up or move forward. All right, next thing we're going to work on is write the product as a power. So this is super simple. If you see 12 times 12 times 12 times 12, the base would be 12 and the exponent would be 4. So that means we're multiplying 12 times itself 4 times. Your answer would be written as 12 to the 4th power. Next one, what if we have 10 times 10 times 10? Your base is 10, your exponent is 3. Remember, that's read as 10 cubed. Anytime your exponent is the number 3, we're always going to read that as cubed. 2 times 2 times 2 times 2 times 2, I see the base is 2. I see 5 2s, so that would be written as 2 to the 5th power. Perfect squares, another pretty simple concept. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9, 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144. We could keep going on forever and ever and ever, but we don't need to do that. So 1 is a perfect square because it's the answer is found by multiplying a whole number times itself. 4 is a perfect square. 9 is a perfect square. So the product, the answer to a multiplication problem, when you've multiplied a whole number times itself, is called a perfect square. And the last thing we're going to talk about are powers of 10. So all this means is that 10 to the first power is simply 10. 10 squared means 10 times 10. 10 times 10 is 100. 10 cubed, or 10 to the third power, means 10 times 10 times 10. Well, 10 times 10 is 100. 100 times 10 is 1,000. 10 to the fourth power, 10 times 10 times 10 times 10. Well, I know 10 times 10 is 100. I know 10 times 10 is 100, and 100 times 100 is 10,000. Now, before we go on, I'm going to show you something. Notice that the exponent here was 1, and how many zeros do we have in our answer? 1. Notice the exponent was a 2, and how many zeros in the answer? 2 zeros. Notice the exponent for cubed was a 3. How many zeros? 3. Our exponent was a 4. How many zeros in our answer? 4. So this is really mental math. You don't have to do all of the multiplying when you're doing powers of 10. All you have to do is put a 1. If your, oops, sorry, didn't mean to do that. If your exponent is a 5, behind that 1, you're going to add 5 zeros. 1, 2, 3, 4, 5. So that would be 100,000 with 5 zeros. 10 to the 6th power, put a 1. If your exponent is a 6, you're going to add 6 zeros. 1, 2, 3, 4, 5, 6. So that would be 1 million with 6 zeros behind it. 10 to the 8th power, put a 1, and then 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that would be 100 million. 10 to the 10th power, put a 1 with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma, comma, comma. All right, 10 zeros. So that is it. That is your lesson for today. So now you're going to go back to Canvas, and you should see worksheet 10. You're going to try those problems for me. If you are sick right now, home, quarantined, or sick with anything else, you're going to complete worksheet 10, and then please email me your completed copy. All right, if you need to go back and watch the video again, you can do that. Have a good day.